welcome to the deep dive. If you're the kind of person who, loves a really good aha moment and you want to stay ahead of the curve without just drowning in tech jargon, you are definitely in the right place.
Absolutely. Because today we're looking at something that honestly feels like a magic trick.
It really does. I mean, our mission for this deep dive is to solve basically the ultimate modern tech dilemma, which is how do you make AI incredibly smart without it being incredibly slow or, frankly, just astronomically expensive?
Right. Because for decades, the rule was just build a bigger machine. You want smarter AI. You burn more electricity.
Yeah, you just throw more money and power at it. But today, we're looking at how the smartest minds in the industry are actually doing the exact opposite. They are shrinking geniuses. And our source material today is this really fantastic narrative-driven article by Aaron Rose from tech-reader.blog. It's called The Secret Life of Azure, the Model Distiller.
And what's so great about this piece is that Rose doesn't just hit you with a white paper. He grounds all this complex math in a story.
Yes. He uses these two characters, Timothy and Margaret, to explain it, which I love because it brings it all down to earth.
Exactly. It makes the abstract concepts feel incredibly real.
So, to set the scene, the article starts with Timothy, and he's standing there, holding a green marker, just staring at two different computer screens, and he's trying to build an AI system for his library.
Right, and he is paralyzed by this choice between the two screens because they represent the two total extremes of AI right now.
On the first screen, he's got what the article calls the lead planner. Basically, this is your massive frontier class model. Think like GPT-4o.
The heavy hitter.
Right. And the output is gorgeous. It's perfectly formatted. It's got the super professional tone. And Timothy notes it has nuance. Like, it really gets the layered context of a library.
But the downside is massive.
Oh, huge. Because every single time someone asks where the bathroom is or where the sci-fi section is, you're spinning up this gigantic digital brain. It's slow and it's so resource heavy.
Which pushes Timothy to look at the second screen. And that one is running the Phi-3 Scout.
Right, the Scout.
Yeah, which is a small language model or an SLM. And this thing is, well, it's lightning fast.
Blazing fast.
Exactly. It gets the facts right. Almost zero latency. But Timothy, he hates reading it.
He calls it robotic.
Robotic and clumsy. He actually says it lacks the library soul.
The library soul. Okay, let's unpack this because I think we've all interacted with chatbots that feel like that. It's like, it feels like having to choose between a Michelin star chef who takes 5 hours to make dinner.
Right.
And then on the other hand, you've got this fast food fry cook who hands you a meal in 30 seconds, but it has absolutely no soul.
That's a perfect analogy.
Yeah.
You get technically edible food, but no culinary artistry.
Yeah. And we've just been told for years that we have to accept this trade-off. You want speed, you get the fry cook. You want the masterpiece, you wait 5 hours and pay a fortune.
But that's where Margaret comes in. She's his colleague in the story, and she completely rejects that trade-off.
She steps up to the whiteboard, right?
Yeah. She draws this visualization. On one side, she draws a really large, ornate book. That's the lead planner, the giant model.
The Michelin star chef.
Exactly. And on the other side, she draws a small, blank notebook, the Phi-3 Scout. And she points to the space between them and calls it the intelligence gap.
The intelligence gap.
Right. And her whole proposal is, we don't choose. We bridge the gap. We turn the big ornate book into a teacher for the small notebook.
Okay, and in the article, she draws this arrow of light flowing from the big book to the small one, which is super poetic. The master passing down the ancient secrets.
It's very cinematic.
It is. But, and this is where I start getting a little stuck on the actual engineering of it. How do we actually move a brain?
Well, you don't.
Right, because, I mean, do we just copy-paste the code? If we just dump the big model's code into the small one, doesn't the small one just become big and slow?
100%. If you just copy the architecture, you destroy the very thing that makes the small model great, which is its speed and efficiency. So Margaret makes this vital distinction. She says, we don't move the brain, we mirror the reasoning.
Mirror the reasoning.
Yes. That is the absolute core of model distillation.
Okay, so wait. Usually you train an AI by just feeding it a mountain of facts, right? And it guesses the next word. So how is this different from just giving the small model a bunch of right answers?
Because if you just give it the final answers, it's just memorizing an answer key.
Right.
It's not learning how to think.
Oh, I see.
The real secret sauce here is capturing what they call the chain of thought.
The chain of thought.
Yeah, so they take the massive model, the lead planner, and they run thousands of really complex library queries through it. But they don't just save the final answer. They save the why behind it.
So back to our kitchen analogy, they aren't just having the fry cook watch the Michelin chef hand a plate to a customer.
Right. They're having the Michelin chef write down exactly why they turned the heat down at minute 3, why they added a pinch of salt instead of pepper.
Step by step.
Exactly. The logic, the structural choices, the tone adjustments.
Yeah.
And all of these whys get compiled into what Margaret called the gold standard data set.
The gold standard data set. Okay, so we're making the small model study the genius's homework, complete with all the scratchpad notes in the margins.
You got it.
But wait, I have a problem with this, and Timothy actually points this out in the article too. It's a massive logical obstacle.
The data drought.
Yes.
Yeah.
If we need thousands of incredibly complex, nuanced queries to teach the small model, where are we getting them? Like, I don't have a million real-world crazy edge case questions sitting in a filing cabinet.
Most businesses don't. You might have a few hundred standard FAQs, but that's not nearly enough to train a neural network.
Right. So what do they do?
This is where Margaret draws a sparkling icon on the whiteboard.
Yeah.
Because they introduce a concept called synthetic data generation.
Synthetic data, meaning it's fake.
Fake in the sense that a human didn't ask it. They actually ask the massive model, the lead planner, to imagine its own test questions.
Wait, really?
Yeah. They say, hey, dream up 1,000 insanely difficult scenarios that Timothy might face in this library.
So the AI is basically role-playing as a chaotic patron.
Exactly. The article mentions they ask it for weird cataloging errors or complex user requests that span different historical periods, just wild edge cases.
And then the same giant model turns around and acts as the expert, generating the perfect step-by-step answer for the crazy question it just made up.
Which is such a brilliant concept. The article phrases it perfectly. We are using the genius to dream up a curriculum for the specialist.
The big model writes the textbooks that the small model is going to study. That is, wow, that's wild.
It solves the data drought instantly.
Okay, so we have the textbooks now. We've got this synthetic curriculum full of edge cases and perfect reasoning. But how does the Scout actually absorb it?
Right, because reading a textbook isn't the same as understanding it.
Exactly. So how do we bake this into the small model?
So on the whiteboard, Margaret draws a small forge, like a blacksmith's forge.
Oh, to represent, like, reshaping metal with heat.
Exactly. This is the technical phase called instruction fine-tuning.
Instruction fine-tuning.
Yeah. They take that massive synthetic curriculum, and they basically bake it into the Scout's weights.
Okay, and just to clarify for everyone, the weights are the mathematical connections inside the AI's brain, right?
Right. The pathways it uses to process information. By running the small model through this perfect hyper-specific data over and over, they permanently alter its internal structure.
So if I'm understanding this, we aren't trying to teach it everything about the entire world.
No, not at all.
Like, we aren't giving it a generalized liberal arts degree where it has to know quantum physics and how to write a sitcom and ancient Roman agriculture.
Right, that's what the giant model is for.
We are giving this small model a hyper-specific PhD in just this one library.
Yes. And that is what makes it a domain expert.
A domain expert.
Because it doesn't need to hold the entire internet in its brain. It can stay small. It keeps its blazing fast speed.
But because it's studied under the master, it gains that elegant vibe. It gets the layered reasoning without the bloat.
Exactly. It speaks library fluently now.
Which brings us to the payoff. Because Timothy finally sits down to run a test on the newly forged Scout.
The moment of truth.
Right. And he throws an absolute curveball at it. The article says he asks it a nuanced question about an obscure 18th century binding.
A real test of its domain expertise.
Yeah, he's not asking for the bathroom code. And the result is, well, it's totally triumphant.
It comes back in milliseconds.
Milliseconds. But this time, it's not robotic. The tone is elegant, the reasoning is layered, and the formatting matches the giant lead planner perfectly.
The amateur has graduated.
Timothy actually says it's a pocket-sized version of the master.
It's such a great payoff.
It is. But I want to pivot here directly to you, the listener. Because why does a story about a librarian testing AI matter to you and your tech stack?
It matters because of the cost and the speed. This process proves you don't need a massive, incredibly expensive supercomputer to get genius-level, nuanced AI assistance anymore.
Right. You don't have to hire the Michelin chef every single time you want a good sandwich.
By shrinking a genius, we can take that elite-level domain expertise and run it efficiently on much smaller devices.
So you could run it locally, like on a smartphone or in your car.
Or on a hospital server where privacy laws mean you can't send data to the cloud. You get top-tier performance with low latency.
which perfectly sets up Margaret's final quote in the article. She says, and this is the ultimate takeaway here, when you can shrink a genius, you don't just save time, you democratize excellence.
Democratize excellence. It's not just for the massive tech giants anymore. It's everywhere.
It's everywhere. So just to quickly recap this insane journey, we started with this clunky robotic small model. Instead of just giving it facts, we used model distillation to capture the step-by-step chain of thought from a massive genius model.
The why, not just the what.
Right. And to fix the data drought, we use synthetic data generation, letting the giant model dream up its own edge case curriculum.
Role-playing the chaotic patron.
Yeah. And finally, through instruction fine-tuning in the Forge, we baked all that brilliance into the small model, turning it into a blazing fast, nuanced domain expert.
It really is a massive leap forward.
It is. But, looking at all this does leave me with a completely wild, final, provocative thought for you to ponder. Something that kind of builds on Aaron Rose's article.
Intrigue.
Well, think about the synthetic data part. If massive models can synthesize data perfectly enough to train smaller models, what happens to the future of human-generated data?
Oh, wow.
Right? Like, imagine a future where these giant teacher models don't even interact with humans anymore.
They're just behind the scenes.
Yeah. Maybe their only job will be to act as these ultimate professors locked away in isolated digital universities, endlessly dreaming up new edge cases just to train the millions of pocket-sized masters that actually live in our phones and cars.
An entire ecosystem of machines teaching machines.
Exactly. And it makes you wonder who is really teaching who at that point.
That is a wild thought to end on.
It really makes you think. Thank you so much for joining us on this deep dive. We hope this gave you a few of those aha moments and a clearer view of the road ahead. Keep questioning, keep exploring, and we'll see you next time.